Today I'd like to talk about internal rate of return and incremental investments. You recall in previous lectures we talked about different ways of assessing alternatives. We've looked at present worth comparisons, annual worth comparisons, and we've also looked at rate of return comparisons using the internal rate of return and comparing it against the minimum acceptable rate of return, the MAR. Now, when one makes internal rate of return comparisons, it's a little more complicated than with the other comparison methods. We looked at just calculating an internal rate of return before, but when making comparisons, it's a little more difficult because it's insufficient to look at just the value of the internal rate of return. One has to look at incremental investments. For example, imagine we have 4 projects with different first costs and different internal rates of return based upon savings that are accrued from those first costs. We're given a MAR of 12%, and the question is, well, which of these projects should we take? Intuition might suggest several different answers. For one thing, we can see that one of the projects down here has an internal rate of return of 22%. It's like earning interest of 22% on that investment. That's earning such a large amount of interest that you'd think, well, let's just do that project. That's the best thing we can do. On the other hand, another point of view says, well, we want to earn more than 12%, and the more money we can invest at a higher rate of return than 12%, the better. So maybe we should invest in a project that costs $40,000, because then 40,000 of our dollars are being invested at a high rate of return, at 15%, which is above our minimum acceptable. Another point of view says, well, why not invest in all of them? They're all at least at our MAR, and we haven't been told anything to suggest that we can't do all of them. So why not do all of them? Well, all these answers have some merit, but here's the proper point of view. We do want to invest in all projects that exceed our MAR, if we can. So if, in fact, these projects were all independent, then we would invest in all of them. On the other hand, these might be competing projects. They might be mutually exclusive. You can only do one of them, or one of 2, or something like that. And where projects are mutually exclusive, you only can invest in one. And the choice of which one to invest in is where this idea of the incremental investment comes in. So it's not simply if they're mutually exclusive to pick the one with the highest internal rate of return. The process is more complicated, and that's what I want to talk about today. Here's an example problem. Waterloo Meats can buy a slicer system for $50,000. So this would be for slicing cold cuts. And with that slicer system, they can earn an internal rate of return of 25%. They can buy the same system with an extra feature, an automatic loader, costing them $60,000 instead of the $50,000 for the basic system. The second system, the larger one, has an internal rate of return of 22%. The loader saves them an additional $2,500 per year over the 8-year life of the slicer. Their MAR is 20%, should they buy the automatic loader. So if we look at the internal rate of return of these 2 projects, the one basic loader and the one loader with one basic slicer and the same slicer with a loader, we can see that both systems exceed the minimum acceptable rate of return. There might be an intuition to suggest, well, let's buy the more expensive one, because we're still earning more money than our minimum acceptable rate of return. But let's look at this in 2 stages. We can buy the simple loader, the simple slicer, and earn 25% interest. If we go to the more complicated slicer with the loader attached, what we're really doing is investing an extra $10,000. We're investing an extra $10,000 for a return of $2,500 per year. The way we should look at this is accept the minimum system, but then look at the internal rate of return of that incremental investment, that $10,000 extra that we can invest. If we assess the internal rate of return of that investment separately, of a $10,000 cost and subtract off the present worth of those $2,500 savings at our unknown interest rate, which will be our internal rate of return over the 8-year life. If we solve this equation for the incremental investment beyond the basic one, we'll get an internal rate of return of 18.7%. So really, for that extra $10,000 investment, we're not earning our minimum acceptable rate of return. It's not a good idea, even though the total investment of the slicer and loader seems to be. So this principle is the one that we have to use whenever we're looking at comparing alternatives, mutually exclusive alternatives, using an internal rate of return comparison. We start with a minimum investment. We then take each increment of investment beyond that and justify it. So this is how we do our internal rate of return comparisons. One step at a time, starting with the cheapest investment and justifying each incremental investment beyond that. I'll be showing you a more complicated example to illustrate this, but I have a little flow chart here which we'll use as we go through the example. Because the process, once you get used to it, it's fairly easy, but may seem a little difficult to start off with. And we'll do this with our next example. What we do is we rank our alternatives from cheapest to most expensive. Now, of course, alternative projects can have all kinds of different cash flow structures. And the process of looking at incremental investment can get very complicated if you have a complex cash flow structure. So the process I'm going to show you really applies to when you have an investment up front, such as buying a piece of equipment, and savings as an annuity over time. If we have more complicated cash flow structures, it can be done, but it's something I don't really want to talk about in this course. It's just too complicated. It doesn't happen that often. So this really applies. We have an initial investment and savings accruing from it. We're also looking at a study period that's the same for all the alternatives. So when we rank the alternatives, we're ranking them for cheapest to most expensive on that initial cost. So we'll call number 1 the cheapest and number n the most expensive. And we go through this flow chart setting values of A and B, where A is the current best alternative and B is, if you like, the challenger. I've noted that down the corner here. So to start with, we start with the cheapest alternative being A, and the next cheapest one being B. This box here checks to see if we've reached the end of our process, looked at all the alternatives. Certainly, we haven't completed it the first time through. N plus 1 in a 2 alternative case would be 3. So the first time through, since B is 2, we definitely not exceed N. So what we then do is look at the internal rate of return of the difference between A and B. If that internal rate of return exceeds the MAR here, if it exceeds the MAR, that means B becomes our new best alternative. That's what this expression here means. This is a computer-like expression. We're not saying that A is equal to B. We're setting the value of A to the former value of B. So if that internal rate of return exceeds the MAR, that means that B is now the best alternative. And that's why A takes on the former value of B, and B moves up. So if, in fact, the increment of the second alternative over the first was, in fact, better than the MAR, then our next pass through this operation would be looking at the second alternative and the third, because we've increased the value of B by 1. However, if the MAR for the increment is less, if the internal rate of return for the increment is less than the MAR, then we simply increase the challenger by 1. So the next comparison would be for the alternative 1 and alternative 3. Now, I understand it seems a little bit abstract that first time through, but now with an example, you'll see it does actually make sense. Here we have Waterloo Aircraft looking at new lathes, each of which has a life of 10 years with no scrap value. We're given a first cost and some annual savings. So this fits the pattern I was describing, where we have equal life for the alternatives, and we have the cash flow pattern of a first cost and then annual savings. We're given a minimum acceptable rate of return, and we want to find out which of these four alternatives should be taken. Using the process that I described in the flowchart, what we do is we start off with alternative 1. Number 1, as you see, as in the flowchart, is the cheapest of the four. To calculate the internal rate of return for number 1 is straightforward. We take the first cost, subtract the present worth of the savings, over the 10-year life. And this gives an internal rate of return of 21.5%. That exceeds our MAR of 15, so we know it's an acceptable alternative. We want to compare now that with alternative number 2, the challenger. This is the current best, number 1. The challenger is number 2. To compare with the challenger, we look at the internal rate of return of the difference. So we check the increment of investment to number 2. That increment would be the first cost for number 2 minus the first cost for number 1 minus the present worth of the savings for number 2 minus the present worth of the savings for number 1, which is 34,000 minus 25,000 times the series present worth factor. And that gives us, for that increment of investment, a present worth, internal rate of return of 12.4%. So, idea is, if we invest in number 1, we get our internal rate of return above our MAR. However, the extra $50,000 we'd be spending for going to lathe number 2, even though it's saving us $9,000 a year, more than number 1, isn't justified. It doesn't exceed our minimum acceptable rate of return. So we don't want to accept investment number 2. We then look for the next most expensive challenger, keeping our best alternative still number 1, because we haven't found anything better. So now we want to compare number 1 and number 3. Looking at the increment of investment here gives an internal rate of return of 16.6%. And here, again, I'm looking at the difference between the first cost and the difference between the annual savings taken to present worth to calculate that internal rate of return between alternative 3 and alternative 1. This does exceed the minimum acceptable rate of return. We now accept number 3 then as being our current best alternative. It's better than number 1 because we're investing more money such that the total amount of money invested is all earning greater than our minimum acceptable rate of return. So 3 now is our best. Our last step is to compare number 3, the current best, and number 4, the last challenger. Again, we look at the difference between the first cost of number 4 and number 3 of $55,000 and the savings between the two, difference of $9,000, and see if we can justify that increment of investment with respect to our minimum acceptable rate of return. That gives us an internal rate of return, that particular calculation, for that increment of 10.1%, which does not exceed our minimum acceptable rate of return. So that gets us through that flow chart. Once we've examined all of the alternatives, the best one that's left turns out to be number 3. So number 3 is best. It's best because number 1 was best. Number 1 was acceptable with respect to our minimum acceptable rate of return. Number 2, the increment to number 2 from number 1 wasn't. So we threw number 2 away. The increment from number 1 to number 3 was acceptable, so we accepted number 3 as being a good investment. The increment from number 3 to number 4 was not acceptable. Number 4 was the last alternative we had to look at. So number 3 was the largest one for which all component costs exceed our minimum acceptable rate of return. So you can see that when you're comparing mutually exclusive alternatives using the internal rate of return comparison method, it's just not as simple as it is with present worth or annual worth comparisons, because you always have to look at that increment. You have to know when to look at that increment. You have to recognize that the alternatives are mutually exclusive. If they're independent, we want to do everything we can for investments that exceed our minimum acceptable rate of return. If they're not independent, then we want to look at each increment of investment. Thank you.